Find the derivative of tangent x squared y equals y cubed minus 4x. We have an implicit equation here. It's an equation involving x's and y's, but it is not solved for y in terms of x, and it's not possible to solve for y in terms of x, and therefore we will have to take the derivative implicitly, which involves taking the derivative of both sides with respect to x, which is indicated by a prime on both sides. Let's start with the left side. The derivative of tangent is secant squared, leave the inside alone, x squared y, but then multiply by the derivative of the inside to complete the chain rule. The inside is a product, x squared times y, so the derivative will be the derivative of the first, 2x, times the second left alone, y, plus the first left alone, x squared, times the derivative of the second. The derivative of y is 1, but then times y prime to complete the chain rule. Every time we take the derivative of a y term, we multiply it by y prime due to the chain rule. Equals to, on the right side, we have the derivative of y cubed, which is a power rule. Bring the power down, subtract 1 from it, but then multiply by y prime to complete the chain rule. That's a y term, and we always have a y prime. The second term, minus 4x, the derivative will be minus 4. So we have secant squared of x squared y times 2xy plus the 1's implied for this second term in parentheses, so we can just write it as x squared y prime equals 3 y squared y prime minus 4. We have two terms that have y prime in them. We will need to isolate those on one side. One of them is the x squared y prime, but it does have the secant squared that will distribute on it. And the other term is the 3y squared y prime. We will want to put those on the same side to isolate the y prime term. I need to distribute the secant squared x squared y before we can do that. So distributing that in, we will have the 2xy times the secant squared of x squared y. I will have plus x squared y prime times the secant squared of x squared y equals to 3y squared y prime minus 4. I have the two terms that have y prime here and here, and I have the two terms that do not have a y prime. I will want to move the y prime terms together on one side and the terms that do not have a y prime on the other side. Since I have this term that's a 4 over here that's already negative, and if I move this to the right it will become negative, I will have two negatives. And if I subtract this over, that'll give me yet a third negative. So I don't want to isolate y prime on the left here. It'll work out either way, but it'll be more negative signs. Let's isolate y prime by moving them to the right. So I'm going to move this term to the right and this term to the left. That will give us fewer negative signs. We have 2xy secant squared x squared y plus 4 equals to, and on the right side I'm going to collect together the y prime terms. I already have the 3y squared y prime, and we subtract over the other term, x squared y prime secant squared of x squared y. By putting the y prime terms on the right side, we have fewer negative signs. Had we kept them on the left, we would have 3 negative signs. Now we have only 1, and it's always best to have fewer negative signs, and this will just go directly to the more simplified answer. We can now factor y prime out on the right, so we will leave the left side alone. And we can factor the y prime on the right, taking the y prime away from each term. And now to solve for y prime, we divide both sides by what's inside the parentheses on the right. And y prime will come out to 2xy secant squared of x squared y plus 4 divided by 3y squared minus x squared, and then secant squared of x squared y. There's our derivative y prime.